10th class maths first lesson. Real numbers exercise 1.4 textbook questions and answers. Exercise 1.4. Question 1. Prove that the following are irrational. I. 112. 2. 3 plus 5. 3. 6 plus 2. 4. 5. V. 3 plus 2 5. Answer. I. 112. On the contrary, suppose that is a 12 rational number. Then 12 is of the form where p, q and q are integers. 112 is equal to pq. 12 1 is equal to qp. I.e., 2 is a rational number and it is a contradiction. This contradiction arises due to our supposition that 12 is a rational number. Hence 12 is an irrational number. 2. Suppose 3 plus 5 is not an irrational number. Then 3 plus 5 must be a rational number. 3 plus 5 is equal to pq. Q is not equal to 0 and p, qz. Squaring on both sides. But 15 is an irrational number. P28Q2/2Q2 is a rational number. P28Q2, 2Q2z, 2Q2 is not equal to 0. But an irrational number can't be equal to a rational number, so our supposition that 3 plus 5 is not an irrational number is false. 3 plus 5 is an irrational number. 3. 6 plus 2. To prove 6 plus 2 is an irrational number, let us suppose that 6 plus 2 is a rational number. 6 plus 2 is equal to pq. Q is not equal to 0. 2 is equal to pq6. 2 is equal to difference of two rational numbers. 2 is equal to rational number, but this contradicts the fact that 2 is an irrational number. Our supposition is wrong. Hence the given statement is true. 6 plus 2 is an irrational number. 4. 5. To prove 5 is an irrational number. On the contrary, let us assume that 5 is a rational number. 5 is equal to pq. Q is not equal to 0. If p, q have a common factor, on cancelling the common factor let it be reduces to ab where a, b are co-primes. Now 5 is equal to ab, where HCF, a, b, is equal to 1. Squaring on both sides we get 5, 2 is equal to ab, 2. 5 is equal to a 2b2. 5b2 is equal to a 2. 5 divides a 2 and thereby 5 divides 5. Now, take a is equal to 5c. Then, a 2 is equal to 25c2. i.e., 5b2 is equal to 25c2. b2 is equal to 5c2. 5 divides b2 and thereby b. 5 divides both b and a. This contradicts that a and b are co-primes. This contradiction arises due to our assumption that 5 is a rational number. Hence our assumption is wrong and the given statement is true, i.e., 5 is an irrational number. V. 3 plus 2 5. To prove 3 plus 2 5 is an irrational. On the contrary, let us assume that 3 plus 2 5 is a rational number. Here p, q being integers, we can say that p3q2q is a rational number. This contradicts the fact that 5 is an irrational number. This is due to our assumption 3 plus 2 5 is a rational number. Hence our assumption is wrong. 3 plus 2 5 is an irrational number. Question 2. Prove that p plus q is an irrational, where p, q are primes. Answer. Given that p, q are primes, hence fp and fq are irrationals. P, q have no factors other than 1, they are primes. Now p plus q is equal to sum of two irrational numbers is equal to an irrational number. Hence proved.